Hello dear students. Today we are going to study third chapter of our 10th class, metals and non-metals. In this chapter we'll be discussing various properties of metals, various properties of non-metals, physical as well as chemical properties, exceptions, then chemical reactions of metals, non-metals, how do metals and non-metals react with each other to form ionic compounds, what are the properties of ionic compounds, etc. But before we begin the chapter, we must know in detail what are metals and what are non-metals. So we'll begin with metals. Metals, they are placed on left side of periodic table. Generally, all the elements placed on left side of periodic table, they show metallic character. Secondly, metals have tendency to lose electron. And therefore, I will say they form cations. The same thing we can put it in another words that metals are electropositive in nature. Also, metals can form monovalent, divalent or trivalent cation. Metal forms oxides and these oxides are basic in nature. This we have studied in our first chapter also, that metals oxides are basic in nature. For example, magnesium oxide when dissolved in water forms magnesium hydroxide, basic in nature. Sodium oxide when dissolved in water forms sodium hydroxide, therefore it is basic in nature. Okay, now we will study what are various properties of metals. In every property you will find that there are some or the other exceptions. Okay, we'll begin with the first one. Metals are generally solid. And its famous exception all of you know, that mercury. It is liquid in nature. It is the only metal which is liquid. Secondly, metals are generally hard. Here also we have exception. Metals like sodium, potassium, they can be cut with knife. They are so soft. Sodium and potassium, they are soft metals. We can cut them as we are cutting a cake or a pastry. From our basic schooling, we know metals are good conductors of heat and electricity. Silver is the best conductor, followed by copper, followed by aluminium. So, silver is the best conductor, followed by copper and followed by aluminium. Now, this question was asked this year in 2020 board exam. Not about aluminium, but which is the best conductor. This question was asked, which is the best conductor of heat and electricity. Again, here we have exception. Comparatively, lead and mercury, they are poor conductors. So with every property you will find one or the other exception. Moving on to the next one. Metals are ductile in nature. That means we can convert them into thin wires. Then that is metals into thin wires. Examples: silver, gold. These are the most ductile metals. Like gold, its formula is Au. 1 gram of gold, we can convert it into a wire of 2 kilometers. It is so ductile, and therefore silver and gold, they were used in hand embroidery, clothings. All antique clothings, they had embroideries of silver and gold because they required very fine wiring of embroideries. Okay. The next is all the metals are malleable. That means we can convert them into sheets, and therefore metals have plenty of uses. For example, like iron, copper, and even aluminium. They are used for making utensils as well as the parts of automobile. Because of their malleable nature, because we can convert them into thin wires. Metals are sonorous. That means they produce sound. And this sound can be produced either by heating the metal or by striking the metal or by beating the metal. And therefore school bell is made up of metal since it produces a sound. Metals are lustrous. You must have seen the new utensil brought at the home. It is so shiny. Even the new metallic box obtained purchased from the market, it will be lustrous in nature. So metals are lustrous. Metals have high melting point. Exception is there. Exception, metals like gallium and cesium. Gallium and cesium, they have low melting point. Now how much low melting point? They can melt when kept on palm. That means these metals can melt even by our body temperature. Very interesting exception. Metals have high tensile strength. Metals show high density. Now there is exception for this. Metals like sodium, potassium and lithium, they are low dense metals. So till now we have seen that maximum exceptions were shown by sodium, potassium, lithium, etc. These are actually alkali metals. So I can say generally alkali metals show maximum exceptions. Now why? About that you will be studying in higher classes. Metals like sodium and potassium, they are stored in kerosene due to high reactivity. Now kerosene, it is an oil. It protects them from reacting, or I will use the word prevents them from reacting with air. Now sodium and potassium are so reactive that they can catch fire when kept in open. They are so reactive, and therefore they are always stored under kerosene. You have to remember this because it is a frequently asked give reason question. So that was all about the properties of metals. Now let us discuss the properties of non-metals. First of all, let us have the basic introduction about non-metals. Non-metals, they are placed on right side of periodic table, like group 13, 14, 15, 16, 17, 18. 13, I will not say 13, but basically group 16, 17, 18, these are non-metals. These groups contains non-metals. Okay. So non-metals, they do not lose, they accept the electron, and therefore they form anion. Like metals, non-metals can form monovalent, divalent or trivalent anion. So due to this nature, we will call them electronegative. So we say non-metals are electronegative in nature. Non-metal react with oxygen to form oxides which are acidic in nature. For example, CO2, it is oxide of carbon. We know CO2 when dissolved in rainwater is responsible for acidic rain. Similarly, sulfur dioxide, nitrogen dioxide, all these are oxides of non-metals and they are acidic in nature. In this part, we have discussed the physical properties of metals. So now we will discuss physical properties of non-metals. The first one, these are brittle solids, liquids or gases. I will say graphite is the non-metal which is a brittle solid. Exception is diamond. Diamond is the hardest non-metal. Otherwise, maximum time non-metals exist in liquid or gaseous form. Secondly, these are non-malleable, non-ductile. We cannot convert them into thin sheets or wires. Remaining properties of non-metal includes that they are non-sonorous, non-lustrous, poor conductor of heat and electricity, as well as they have low melting point and boiling point. But again, there will be some exceptions. For example, iodine and diamond, they are lustrous. We know diamond most precious and most lustrous non-metal, and their luster is due to cleavage of planes. Diamond is cut in particular angles and that cleavage gives its luster nature. Poor conductor of heat and electricity, again here is the exception. Graphite, which is the non-metal, is a good conductor of heat and electricity. Exception of graphite we have seen in brittle nature. That is, graphite is a brittle solid. Non-metals have low melting and boiling point. Again here exception will be diamond. So here in this topic we have discussed all differences between physical properties of metals and non-metals, as well as we have seen the differences between chemical properties of metals and non-metals also. Now there are certain elements which exist in more than one form. Their physical nature will be quite different, but their chemical nature will be same, and such property is called as allotropy. About this in detail we'll be studying in chapter 4, but just now I am giving the introduction. What do you mean by allotropy? So what we have seen about allotropy, the property of element to exist in more than one form. For example, graphite, diamond. These both are made of carbon and therefore they will be called as allotropes of carbon. So I will say carbon shows allotropy in the form of diamond and graphite. Similarly, white phosphorus and black phosphorus. These are allotropes of phosphorus. So carbon and phosphorus, these are the two elements that show allotropy. Along with this, oxygen and sulfur, these are also the elements which show allotropy. So this question can be asked, which elements show allotropy? So there are 4 examples. Number 1, carbon. Second, phosphorus. Third, oxygen. And fourth, sulfur. These are the examples which show allotropy. Now based on today's module, let us try to solve some questions on your own. So these are the homework questions for you people. Go through the video carefully and you will find answers of all these questions in this video. Thanks for watching. Have a nice day.